Good day to you all. My name is Mr. Matambo, or the Maths Guru. Today we'll be focusing on trigonometrical equations. Like on the last time, we need to say we're focusing on trigonometrical identities, but now the root is kind of different. Today we will be focusing on trigonometrical equations. Trigonometrical equations. Okay, so looking at the topic of trigonometrical equations, there are things we need to understand. Looking at trigonometrical equations, there are things we need to understand. First of all, we need to understand what we call the quadrants. So when we are dealing with sine theta, this is equal to minus 1 to the power n, then PV plus 180 n. Next, we'll be looking at cos theta. Cos theta is equal to plus or minus PV plus 360 n. And what about tan theta? Tan theta, this is equal to PV plus 180 n. I don't know if you ask me what is called the PV. PV refers to the principal value. So, for you to understand the concept of trigonometrical functioning or trigonometrical equations, we have to know these things. These are only things which help you to answer the questions in a correct manner. Okay, so I'll start by answering the question on solve the equation. Say solve the equation sine 2x is equal to 0,5. For 0 is less than equal to x less than equal to 360 degrees. So rule number 1, let's rewrite the question once again. Sine 2x is equal to 0,5. So by saying 2x is equal to arc sine of 0,5. So now what's the arc sine of 0,5? Using a calculator, the arc sine of 0,5, that's 30 degrees. So we're going to say 2x is equal to minus 1 to the power n, PV plus 180 n, where PV is the principal value. So we are going to replace the PV part with what? With the 30 degrees. We're going to say 2x is equal to minus 1 to the power n. What is our principal value? The arc sine of 0,5, that's 30 plus 180 n. So now we start finding the values because we have a range. The range is from 0 to 360 degrees. So now we say when n is equal to 0, 2x is equal to x. Then we divide by 2, x is equal to 15 degrees. We move on when n is equal to 1. 2x will be equal to 180 minus 30. Then we get 150. We divide by 2, x is equal to 75 degrees. What if when n is equal to 1? When n is equal to 2, we say 180 times 2, that's the 360. 360 plus 30, that is equal to 390. So 2x is equal to 390. We divide by 2, x will be equal to 195 degrees. Then what if when n is equal to 3? When n is equal to 3, we are going to say 180 multiplied by 3, we get a 540. 540 minus 30 we get a 510. So 2x is equals to 510 degrees divided by 2, divided by 2. Then our x will be 255 degrees. Now, if we want to get the n is equal to 4, we then say 180 times 4. Then we get 720 degrees. 720 plus 30, which is our principal value. Then we get 750. 750 divided by 2, we get 375, which will be out of the range. So now this is all for the question when solving the sine quadrant. Remember, when solving the sine quadrant, you simply say minus 1 to the power n PV plus 180n. You only get the principal value when you need to say at sine of 0.5, which is equal to 30, and your 30 will be your principal value. Now we move on to the next question, whereby we'll be dealing with the quadrant of cos theta. So the question says, solve the equation cos 2x is equal to 0.5 for 0 is less than equal to x less than equal to 360 degrees. Now, let's rewrite the question once again. We're going to say cos 2x is equal to 0.5. First things first, we need to find the principal value. Remember, the quadrant of cos theta is equal to plus or minus PV plus 360n. So we are going to say 2x is equals to a cos of 0.5. So 2x is equals to plus or minus. Now, what is the a cos of 0.5? The a cos of 0.5, that's 60 plus 360n. Then now, we start by finding the values. So first of all, we say when n is equal to 0, when n is equal to 0, 2x is equal to positive 60. Since our range is ranging from 0 to 360 degrees, we divide by 2, Then our x will be equal to 2 into 60, that's 30 degrees. Then we move on to the next question, to the next value when n is equal to 1. 2x is equal to 360 minus 60, we get 300. Then we divide by 2, then our x will be 150 degrees. Then on the same value when n is equal to 1, we are going to take 60 when it's positive. So we say 360 plus 60, 2x is equal to 420 degrees. Let's divide by 2, x is equal to 210 degrees. Now move on when n is equal to 3. When n is equal to 2. So what is when n is equal to 2? We're going to say 360 times 2. 360 times 2. We are going to get 720. 720 minus 60. We'll be left with the 660. Then say 2x is equal to 660. Let's divide by 2. X is equal to 330 degrees. Now this marks the end of our value since we are ranging from 0 to 360. Any other value, when we say n is equal to 3, we get a higher value which cannot be true for our solution. Now we move on to the tan quadrant. So for the quadrant of tan, you have to remember, when dealing with tan, we say PV plus 180n, where PV is the principal value. So the question says, solve the equation tan 3x is equal to 1 for 0 is less than equal to x less than equal to 360 degrees. So all you need to remember, we're going to rewrite the question once again. Now we're going to say tan 3x is equal to 1. We say 3x is equal to arctan of 1. By saying total of 1, this becomes the principal value. So what I'm going to say now, I'm going to say 3x is equals to PV actual of 1, that's 45 plus 180. Then we need to find the value. This ranges from 0 to 360 degrees. What I'm going to say, I'm going to say when n is equals to 0, when n is equals to 0, 3x is equals to 45 divided by 3 divided by 3. We get our x is equals to 15 degrees. Now we move on. When n is equals to 1, when n is equals to 1, 3x is equals to 180 plus 45. 180 plus 45. Hope you're all holding your calculators. 180 plus 45, that is equal to 225. So the 225 divided by 3 is 75. X is equal to 75 degrees. We move on. When n is equal to 2, when n is equal to 2, 3x is equal to 180 times 2. That's 360. 360 plus 45. We get 405. So 3x is equal to 405. We divide by 3. We divide by 3. Then we are left with x is equal to 405 divided by 3. We get a 135 degrees. Wow. This is ever interesting. Now we have a lot of values that we're going to deal with. What if when n is equal to 3? When n is equal to 3, we are going to say 180 times 3, which is equal to 540 plus 45. We get 585. So 3x is equal to 585. We divide by 3. We divide by 3. Then our x will be 105 degrees. As long we are still in the range, we keep on putting the values once again. So we're going to say, what if when n is equal to 4? When n is equal to 4, we are going to say 180 times 4. Then we get 720 plus 45. Then we get 765. So 3x is equal to 765 over 3 over 3. Then our x will be divided by 3. We get 255. As long as we're still in the range, we keep on finding the values. What if when n is equal to 5? When n is equal to 5. When n is equal to 5, we're going to say 180 times 5. 180 times 5. We get a 900. 900 plus 45. We get 945. So I'm going to say 3x is equal to 945. Let's divide by 3. Let's divide by 3. Then our x will be equal to, divided by 3, we get 315 degrees. So now any number above 315 will be out of the range, since our range is equal to from 0 is less than equal to x, less than equal to 360 degrees. So this was all for the sine quadrant, cos quadrant, and tan quadrant. But the examiners don't give you simple questions like this one. I'm going to give you a simple question, which was from one of our past exam question papers. The question here to say, solve the equation 3 sine x tan x is equal to 8. For 0 is less than equal to x, less than equal to 360 degrees. Remember, on our last topic, we were dealing on trigonometrical identities. We were dealing on trigonometrical identities. So, for you to answer this question, clearly you have to remember what is the identity of tan x. On our last topic, I had to say tan x is equal to sine x over cos x. So, I can rewrite again the question. 3, okay, that's it. 3 sine x. So that's 3 sine x. Sine x is equal to 8. So we're going to say 3 sine x. Now the identity for tan x is equal to sine x over cos x is equals to 8. So we multiply, we're going to be left with 3 sine squared x over cos x is equals to 8. So now we do the cross multiplication. We're going to say 3 sine squared x is equals to 8 cos x. Now, what is the identity of sine squared x? From our last topic, we had to say sine squared x plus cos squared x is equals to 1. So the identity for sine squared x equals 1 minus cos squared x. So I'm going to say 3 open bracket 1 minus sine squared x is equals to 8 cos x. So that's 3 minus 3 sine squared x is equals to 8 cos x. So let's all put them on one side. We are going to be left with 3 sine squared x plus 8 cos x minus 3 is equals to 0. So for you to calculate this in a simple manner, you are going to let sine x is equals to y. Let sine x is equals to y. Okay, so now we are going to say, if now sine x is equals to y, we are going to say 3y squared plus 8y minus 3 is equals to 0. Now we do the simple factorization. So now let's factorize together. We are going to say, what are the factors which gives us 9? If we multiply, and the same factors gives us 8 if we add or subtract. So we are going to say 3y squared plus 9y minus y minus 3 is equals to 0. So that's 3y, y, it's a y plus 3 minus 1, y plus 3 is equals to 0. So that's y plus 3, 3y minus 1 is equals to 0. So now let's solve for the values of y. So our y is equals to minus 3 or 1 over 3. But the examiner did not ask us to find the values of y. We want to find the values of what? Sine x. So okay, something is messed up here. Something is messed up here. Okay. We didn't factorize correctly here. Let me highlight. Okay. Here. We didn't do the correct thing. Yeah. We didn't do the correct thing. This part is correct. So we want to remake this part. So let me do this. Okay. Basically, what is the identity for sine squared x? Sine squared x is equals to 1 minus cos squared x. So once again, this becomes 3 minus sine squared x here. Okay. So that's 3. That's it. 3 minus 3 cos squared x. So this whole equation is in cos form. Okay. This becomes 3 cos squared x. So now we are going to let cos x okay, let cos x. Yeah, now this becomes very, very correct. Okay, I did substitute the correct identity for sine squared x. I had to say sine squared x is equals to 1 minus sine squared x, which marks it wrong. Okay, sine squared x equals 1 minus cos squared x. Now we have 3 minus 3 cos squared x equals 8 cos x. Now 3 cos squared x plus 8 cos x minus 3 is equal to 0. Now let cos x is equals to y. So we need to find the values of cos x. We are going to say cos x is equals to minus 3, or cos x is equals to 1 over 3. So by finding the arc cos of minus 3, it becomes wrong, whereby we say it's non-applicable. Why is it non-applicable? It's non-applicable because the graph of cos theta ranges from 1 to -1. So now you'll be left with this value only. You can say x is equal to the arc cos of 1 over 3, which is equal to plus or minus arc cos of 1 over 3, that's 70.5 plus 360 n. So when n is equals to 0, x is equals to 70.5, and when n is equals to 1, so again say 360 times 1, that's a 360 minus 70.5. Since we are saying plus or minus, this becomes x will be equal to 289.5 degrees, and this answer will be correct. So that's all for the question of solve the equation 3 sine x tan x equals to 8. By the way, this question can even hold 6 marks when it is in the examination. So the first thing you need to understand with this question is whereby you change the tan x, the identity for tan x. Tan x is equal to sin x over cos x. This is the first aspect. The second aspect is whereby now you change the identity of sin squared x. Like I said, sin squared x equals 1 minus cos squared x. For it to be simple for you to calculate this kind of mathematics, you need to know the basic principle of what factorization. To let cos x is equals to y. I was left with 3y squared plus 8y minus 3 is equals to 0. Then by doing simple factorization, our factors will be minus 3. And for this minus 3, it becomes non-applicable. Since for the last time I had to teach you on drawing the basic graphs of sine theta and cos theta, I had to say the graph of sine theta or cos theta ranges from 1 to -1, where 1 will be the amplitude. So for the cos of any other number which is greater than 1, or which is less than -1, it becomes an error. By using your calculator, you get this value as error 2. So I'll move on to the next question. The next question comes from the past exam question paper. So I'm going to look at the past exam question paper, whereby I need to find another simple equation, which makes the topic very, very easy. Because moving on this topic, we're going to do the harmonic form. So let me find a paper. Okay. That is June 2016, paper 1. Yeah, June 2016, paper 1. Okay, so on June 2016, paper 1, that is equals to, on number 10, there was a question you're saying that's June 2016. That's 2016, paper 1, question 10. Okay, on number 10A, there was a question saying prove the identity. Prove the identity tan squared theta minus sine squared theta is identical to sine squared theta tan squared theta. So this was the first question, and on the B part, it was saying solve the equation. Solve the equation for sine squared theta tan theta minus tan theta is equals to 0 for 0 is less than equal to x less than equal to 2 pi. So the question one is in radians. The question was in radians. So the first question, I'm going to prove the identity. I am going to prove the identity. So now help me to prove the identity, because this was the topic we did on our last live. So tan squared theta minus sine squared theta is identical to sine squared theta tan squared theta. So first and foremost, we need to change this tan squared theta to the identity. Tan squared theta is equal to what? Sine squared theta over cos squared theta minus the sine squared theta is identical to the right hand side. Now we need to look for the common denominator. So what is the common denominator of this? That's cos squared theta. Cos squared theta. So cos squared theta into cos squared theta, that's a 1. 1 times sine squared theta, we get a sine squared theta minus. Now, what is 1 into cos squared theta? That's a cos squared theta. Cos squared theta times sine squared theta, we're going to get sine squared theta cos squared theta. Now we need to factor out sine squared theta. Then we'll be left with 1 minus cos squared theta. So all over cos squared theta. Now we get sine squared theta. What is 1 minus cos squared theta? Also get sine squared theta. All over cos squared theta. Now let's break down this thing. So this is all identical to the right hand side, or identical to the right hand side, or identical to the right hand side. Make sure you put the identical parts right. So now we have sine squared theta sine squared theta over cos squared theta is identical to the right hand side. So we need to write down this as it is. So this becomes sine squared theta. So what is sine squared theta over cos squared theta? That is equals to a tan squared theta is identical to the right hand side. Now this part will be proved. So this is a simple arithmetic which you need to understand the concept of trigonometrical identities. But remember, when you give them such questions like this in the B part, it simply means that a sum of the part of our answer, we're going to use it once again on the first part. So this is all for improving the first part. Now I move on to the second part of solving the equation. So this is ever simple. This is ever simple, because all you need to do is to remember. So I move on to the question on solving the equation. So I will rewrite again the equation, which is saying 4 sine squared theta tan theta is equal to minus here tan theta is equals to 0. So for this kind of mathematics to be simple, first of all we need to make this tan theta positive. So it becomes 4 sine squared theta tan theta is equals to tan theta. So Since there are tan theta on both sides, we simply divide by tan theta. So I'll be left with 4 sine squared theta is equals to 1. Then I divide by 4, I divide by 4. I'll be left with sine squared theta is equals to 1 over, not the plus minus, that will be equal to, okay, that will be equal to 1 over 4. Now we need to remove the square part. We're going to say sine theta is equals to plus or minus the square root of 1 over 4. Since the square root of a number is either plus or minus, the square root of a number is either plus or minus. So sine theta is equals to plus or minus 1 over 2. So we are going to say sine theta is equals to half, or sine theta is equals to negative half. So for us to find the values of theta, like I said, when dealing with the quadrant of sine theta, we say plus or minus 1 to the power n, PV plus 180 n. So now we need to find the principal value, whereby we are going to say theta is equals to, so when you have your calculator, simply change your calculator to the radiant mode, whereby we say theta is equals to arc sine of half. So now what is arc sine of half? Arc sine of half, that is equal to pi upon 6. So this is equals to minus 1 to the power n pi upon 6 plus 180 n. So now we start by saying when n is equal to 0, our theta is equals to, when n is equal to 0, our theta will be pi upon 6. What if when n is equal to 1? When n is equal to 1, we are going to say, I need to say 180n. So we need to replace the 180n by pi. Let's replace it by pi since we are on the radian mode. So that by pi n. So when n is equal to 1, we are going to say pi minus pi upon 6. Then we get theta is equal to 5 pi upon 6. Then we move on to, what if when n is equal to 2? When n is equal to 2, it will be out of range since we are dealing from 0 to 2 pi. So we move on to the other principal value, whereby we say theta is equal to arc sine of negative half. So when you have your calculator, you're going to say second function, the arc sine of negative 1 over 2. Then you get negative pi upon 6. So that will be equal to minus 1 to the power n negative pi upon 6 plus pi n, since we are in the radian mode. So now we say when n is equal to 0, when n is equal to 0, our value becomes negative pi upon 6, which cannot be true according to our range, because our range is saying from 0 to 2 pi. So we start by saying when n is equal to 1, when n is equal to 1, when n is equal to 1, whereby we're going to say pi plus pi upon 6. Then we'll be left with 7 pi upon 6. 7 pi upon 6. Which is true. So we are saying that this will be our last value, since we are ranging from 0 is less than equal to x less than equal to 2 pi. So for any other values that you want to find, you can keep calculating. When your answer is still in the range, this will be your correct answers. Now I move on to the next aspect of harmonic form, since we are done on doing the trigonometrical equations. Okay, so the part that I want to do is called harmonic form. Be attentive, because this is a crucial topic. In every examination, there will be a question of harmonic form. So others are asking me what is called the harmonic form. So harmonic form in mathematics, harmonic form. So we'll begin expressing a sine theta plus b cos theta in the form r sine theta plus alpha. So I want you to be attentive to me, because this is a crucial topic. So first of all, you need to understand which one starts first. Is it sine theta or is it what? Cos theta. So first of all, given a sine theta plus b cos theta. So since the question is starting with sine, this whole equation will be for sine. You can say r sine theta. When the sine is 18, sine also 18. Sine theta plus alpha. A sine theta minus b cos theta. This is equal to r sine theta minus alpha. Then now, if we are starting with cos, a cos theta plus b sin theta. So cos always opposes things. Like I said on the last time when I was dealing with cos a plus b, I was saying cos a cos b minus sin a sin b. So this is the cos that we're doing. So for cos is r cos theta. When cos is adding, it subtracts here. Cos theta minus alpha. What if it's a cos theta minus b sin theta? This is equals to r cos theta plus alpha. So this is a plus here. Plus, don't put a multiplication sign here. That's a plus sign here. So others are asking me, how do you find r? So r is very simple to find. So when finding r is equal to the square root of a squared plus b squared. What is now alpha? Alpha is equals to tan b over a. So when finding the tan, which is our alpha, do not put any sign in here, because now the sign is ever compressed with what? With the formulas. So never ever put a sign on A and B. Remember, we have the formulas that we are dealing with. So I'll repeat once again. A sine theta plus b cos theta, that is equals to r sine theta plus alpha. A sine theta minus b cos theta, that is equals to r sine theta minus alpha. What is what? A cos theta plus b sine theta, that is equals to r cos theta minus alpha. Like I said before, cos is ever opposing. Whenever cos is adding here, it went on subtracting. And whenever cos is subtracting here, it went on adding. So for r is equal to the square root of a squared plus b squared. And alpha is equal to tan of b over a. Now I'll put a question for illustration so that you can even understand this concept or this topic. So for those who are working with me, remember to like, share and subscribe the page, and likewise you get cheaper stuff, easy to understand. So now I'm going to put a question. The question says, the A part says, express 3 sine theta. Let me put here minus 4 cos theta in the form r sine theta minus alpha. Then the B part says solve the equation 3 sine theta minus 4 cos theta is equals to root 2. For 0 is less than equal to x less than equal to 360 degrees. Then the C part says find the maximum and minimum value of y over 3 sine theta minus 4 cos theta plus 7. Okay, now I want to tackle this question or this concept with a simpler method. So, like I said before, all you have to do is to remember finding r and finding the alpha. So, the question is saying 3 sine theta minus 4 cos theta. So this is equals to this is identical to r sine theta minus alpha. So for r, like I said before, this is equal to square root of a squared plus b squared, which is equals to the square root of 3 squared plus 4 squared, square root of 9 plus 16, square root of 25, which is equal to 5. Now what is alpha? Alpha is equal to arctan of b over a, which is equals to arctan of 4 over 3. So by calculating the arctan of 4 over 3, that is equal to 53,1, if not mistaken. Now we are dealing with the degrees. Okay, so make sure that your calculator is in degree mode. So second function, arctan of 4 over 3. Then we get 53,1. This is equals to 53,1 degrees. So therefore 3 sine theta minus 4 cos theta is identical to r, that's 5 sine theta minus 53,1 degrees. So this is all for finding in the form r sine theta minus alpha. So now, without removing this part, I just want to remove this part so that I'll be able to work out the second part. So on the second part is saying solve the equation 3 sine theta minus 4 cos theta is equals to root 2. So say 3 sine theta minus 4 cos theta is equals to root 2. So I'll rewrite it again. 3 sine theta minus 4 cos theta is equals to root 2. Already we have the 3 sine theta minus 4 cos theta is expressed on this part. It's saying 3 sine theta minus 4 cos theta is equals to 5 sine theta minus 53,1. So I will replace by saying 5 sine theta minus Very, very simple. Very, very simple. So, you're going to say sine theta minus 53,1 is equals to root 2 over 5. So, theta minus 53,1 is equals to arcsine of root 2 over 5. So, you need to remember this. Like I said before, when dealing with sine theta, you say sine theta is equals to minus 1 to the power n PV plus 180n. So whatever we are finding by punching on our calculator at sine of root 2 over 5, that will be a principal value. So theta minus 53,1 is equals to minus 1 to the power n. What is now the arcsine of root 2 over 5? That is equal to 16.4, if not mistaken. 16.4 arcsine of root 2 over arcsine of root 2 over 5. That is equal to 16.4. That is equal to 16.4 plus 180n. Right. So since we have the principal value, since we already have now the principal value, we need to find the possible values of theta. So now how do we find them? We're going to say when n is equals to 0. When n is equals to 0, 0 here, 0 here, we are going to be left with theta minus 53,1 is equals to 16.4. So theta will be equal to 16.4 plus 53,1, which is equals to 69.5. Yeah, that's it, 69.5 degrees. What if when n is equals to 1? When n is equals to 1, we are going to say 180 minus 16.4. So we'll be left with theta is equals to 180 plus 53,1 minus 16.4. Since minus 1 to the power n, that is equal to a negative n. So we are going to say 180 minus 53,1. 180 plus 53,1 minus 16.4. Then we'll be left with 216.7 degrees. So all your answers should be in what? Degrees. So this will mark the end of answering the B part. Now I move on to the last part, which some of you don't know, and you need clarification on that. Like I said before, when finding the value of r, we say a squared of a squared plus b squared, right? So I'll move on to answering the third part, which is the C question. So the C question is easy and simple. All you have to do is to remember the value of. So I'll redo it once again. So you need to remember this. For the value of r, we have to say square root of a squared plus b squared, which is equal to square root of 3 squared plus 4 squared, which is equal to square root of 25. That is equals to square root of 25, that's plus or minus 5. But on that part, we have to use it, we have to use 5, which is a positive 5. But now, the question is saying, find the maximum and the minimum value of 1 over 3 sine theta minus 4 cos theta plus 7. So now listen to me very carefully. All you have to do is to say let x is equals to 1 over 3 sine theta minus 4 cos theta plus 7. And now what you're going to do, you are going to replace this whole part with the values of r. So I'm going to say x is equal to 1 over 5 plus 7 or 1 over minus 5 plus 7, which marks 1 over 4 or 1 over 2. Now, by simply checking, you're going to see that our max value is equals to half, and our minimum value will be 1 over 4, and we'll be done for the question. So this marks the end of our trigonometrical equations, trigonometrical identities. Now we move on to the next segment where we want to look and explore on the topic of circle, which is one of the crucial topics in mathematics. So the topic circle is a fundamental question because it requires special formulas to be used. But as for today, I'll be doing this topic in a cheaper way, whereby I will be illustrating a massive concept which you need to understand. So that's a circle. Why did I choose the topic circle? Circle has a relationship with identities. Circle has a relation with identities. So the topic is circle. So first of all, I'm going to teach two methods that you need to understand. So method 1, I'll be focusing on comparing coefficients. Comparing coefficients. So there are things you need to understand. The general equation of a circle is expressed in the form x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. That's the general equation of the circle. It's expressed in the form x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. So the center will be equal to minus g minus f. And for radius will be equal to square root of g squared plus f squared minus c. But NP, for an equation to be a circle, g squared plus f squared minus c should be greater than 0. This is all you need to understand. For an equation to be a circle, g squared plus f squared minus c should be equal to 0. So now I will look on for a question. It is wise for you to remember clearly the equation of a circle, whereby you need to understand that the center will be minus g minus f will be your circle. Also, you need to remember the general equation of the circle x squared plus y squared plus 2gx plus 2fy plus c is equals to 0, and it will be ever easy. So there was a question on this part where it's saying, it was saying find the center and radius of x squared plus y squared minus 2x minus 6y plus 9 is equals to 0. So here is what you do. You simply compare the coefficients. So let's compare the coefficients. The coefficient of x here is 2g, and the coefficient of x is minus 2. So you're going to say 2g is equals to minus 2. The coefficient of y here is 2f. The coefficient of y here is minus 6. Now you're going to say 2f is equals to minus 6. Now let's divide by 2. So g is equals to 2 into 2, that's a negative 1. Then over 2 over 2. Then our f is equals to minus 3. Remember, like I said, center is equals to minus g minus f. So this says minus 1, that's a 1. Then minus 3, that's a 3. And this will be our center. So since we already have the center, we want to find the radius. So for radius, this is equals to square root of g squared plus f squared minus c. This is square root of 1 squared. Okay, it's not showing very clear. So for our radius, we are going to say 1 squared plus 3 squared minus, then the c is 9. Then we'll be left with the square root of 1, which is equals to 1. And that will be our radius. So whenever you are given like any other equation, I'll simply put another question which is different from this one. So all you need is to understand the concept. So it's ever simple. It's ever simple. So the question says find the center and the radius of the equation of the equation 2x squared plus 2y squared plus 4x plus 2y minus 10 is equals to 0. So first of all, I'll rewrite again the question. It's saying 2x squared plus 2y squared plus 4x plus 2y minus 10 is equals to 0. First of all, you need to divide throughout by 2. And you'll be left with x squared plus y squared plus 2x plus y minus 5 is equals to 0. Since 2 divided by 2, that's a 1. So now let's compare the coefficients. So 2g is equals to 2 over 2 over 2. G is equals to 1. 2f is equals to 1, the coefficient of y, over 2 over 2. Then my f will be equal to half. So like I said, center is equals to minus g and minus f here. So which is equals to minus 1 and negative half. This marks the end of finding the center. Now we need to find the radius. We need to find the radius. So already our c here is equals to minus, that is equals to negative 5. That's our c. So I will clear this part so I can write something which is very visible. Okay. So for center is equal to square root of g squared plus f squared minus c. That is equal to square root of g squared minus 1 squared plus minus half squared minus 5. That is equals to, so all you have to do is to use a calculator. Okay, square root of 1 plus 1 over 4 minus 25. That's okay, that's a plus. That's 1 square root of 1 plus 1 over 4 plus 5. So the answer will be 5 over 2, and this will be your this is not the center, that's the radius. That is the radius. Radius here, radius, since we already have the center. So this marks the answer for our radius. So there are more questions which are similar to this thing but kind of different. So I'm going to put another version of another question which is part of the circle but ever different to all of this. Okay, so the question reads this is a very, very interesting question. Find the length of the tangent, the length of the tangent from the point P, from the point P, which has the coordinates 4, 7 to the circle. To the circle x squared plus y squared minus 2x minus 4y minus 4 is equals to 0. So I would draw a circle, and we can even take a look of the things that we need to find. So here's a circle and my radius here, and this is my tangent, and this is point P. So remember, the radius and tangent forms a right angle. So I'm given the point P here, P, which is 4, 7. So the examiner is asking me to find the length of the tangent from point P to the circle. So I need to find this length. This is the length I need to find. But before I do that, I need to find the center and the radius of this circle. So like I said before, the general equation of the circle, that's x squared plus y squared plus 2gx plus 2fy plus c is equals to 0. So we compare the coefficients like already we've been doing. So I'm going to say 2g is equals to minus 2. So I divide by 2, I divide by 2. G is equals to minus 1. What about 2f? Is equal to the coefficient of y, that is minus 4. Let's divide. We're going to be left with f is equals to 2 into minus 4, that's minus 2. And the center is equals to minus g minus f, which is equals to 1, 2. So now we have the center here. So the center here is 1, 2. Now we need to find the radius. Okay, the radius. Like I said before, the equation for the radius is equals to square root of g squared plus f squared minus c, which is equals to square root of 1 squared. Okay, that's a 1. Okay, that's a 1. Alright, that's a 1 squared plus 2 squared minus c, that is equals to minus 4. So that is equals to square root of 1 plus 4 plus 4, which is equal to square root of 9, which is equals to 3. So now our radius is 3. So now already I have what I use to find the length. So now I can even clear this part because it has already helped us to find what we wanted to find. So now already we have the radius. So I'm going to call it this side m. First of all, I'm going to find the length of m. So length of a line, when you are doing coordinate geometry, the length of a line is equals to square root of x minus a squared plus y minus b squared. So now let's find the length of m. The length of m, which is equals to 1 minus 4 squared plus 2 minus 7 squared. This is equals to square root of minus 3 squared plus minus 5 squared, which is equal to square root of 34. Okay, so already this m is equal to square root of 34. We have the length of m, the radius. So now for us to find the length L, we have to use Pythagoras theorem. So let's find L. L squared is equals to root of 34 squared minus 3 squared, which is equal to 34 minus 9, which is equals to 25. So L is equals to, this was L squared. So L is equal to square root of 25, and the length will be 5 units. That is the length of L. So this was the first method on finding the equation of a circle. I move on to the next concept whereby I will be teaching you on how to find the equation of a circle using the simple method. So method number 2. Method 2. So this method will be very, very cheap. Method 2. Completing the square. Okay. So when completing the square, the general equation of a circle. So the general equation of a circle is expressed in the form x minus a squared plus y minus b squared is equals to r squared. So generally there will come a question which will be saying, I'll simply do like the question I had to do on my first question. Find the center and radius of the equation x squared plus y squared minus 2x minus 6y plus 9 is equals to 0. So now let's complete the square together. First of all, we need to group the like terms. So we say x squared minus 2x plus y squared minus 6y plus 9 is equals to 0. So that's x minus 1 squared minus 1 plus y minus 3 squared minus 9 plus 9, right, is equals to 0. So it becomes x minus 1 squared plus y minus 3 squared is equals to 1. So things that you need to remember is this: center, on the formula your center will be a b and your radius will be this. So by comparing the equation, my center here on this equation, center is equals to 1, 3, and r squared is equals to 1. So r is equal to square root of 1, which is equals to 1. So now this marks the end of circle, whereby we are finding the center and radius. So we're going to come back, whereby we'll be doing the Cartesian equation of a circle, whereby you'll be doing trigonometrical identities, applying them to the circle. Thank you for listening.